Okie doke, pause and copy. Okay, so the row space is, well, we take the rows and think of them as vectors. So now we have a row vector instead of a column vector. And we do all the same things, but now the vector is written horizontally. So nothing too seriously different here. Let's look at a theorem. Pause, copy. Okay, so here we have a couple of matrices that are row equivalent. So that means I can do some operations to A and arrive at B, and vice versa. Now what we're saying here is that the row spaces do not change. And in part B, we are given a method for finding a basis for row A. So what you do is you go to echelon form, and what that'll do for you is kind of cut away any fat that may exist in your rows. Oh, let's do an example here. Ooh, exercise rather. So I want you to pause, copy, and try this. I will come through shortly and give a solution. Okay, so we have 3 different spaces here and 3 different methods for finding bases, but they all these methods involve reducing A. So what can I do with A here? Well, I can do a quick pair of operations. Let's just do it in 2 steps. So we have 3 here, that's row 3 minus row 1, right? Yeah, 1, 0, 2, 0, 0, 3, 0, 0, 0. And it's not going to hurt to continue all the way to reduced echelon form. Even though I just need echelon form here, it's not going to hurt me to go all the way to reduced echelon form. Okay, what next? Let's do null A first. So I take this last matrix and write out the corresponding equations. Z equals 0, y. Y, you'll notice y is free here. So I get my vector x, y, z is 0, y, 0, y, 0, 1. So a basis is the set containing a single vector 0, 1, 0. For column space of A. Remember this technique. What do? you look to see that there's a pivot in the first column and a pivot in the third column. So I go back to my original and choose this vector and this vector. Now finally, row A, the technique is different, right? What you do is you take, let's actually scroll up and have the theorem visible again. Okay, so if B is an echelon form, so I have a choice here. I can use this as B, or I can use this as B, because that is an echelon form, and this is also in echelon form. Okay, this last one is in reduced echelon form, but it's also in echelon form. Okay, so I'll use the last one. And I will choose as my basis elements this row and this row. So a basis is 1, 0, 0, 0, 0, 1. Row vectors. Now, if you choose this guy and this guy instead, that is also correct. Okay, that's why I say a basis, not the basis. There are an infinity of correct answers here. Okay, moving on. I'm sorry. What do I want to have here? Okay. I want you to pause and copy all this quite a bit here. Don't worry, I'll talk about it once you're done. Pause, copy. Beep, 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 boop, 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 beep, beep, beep. Okay, the rank of a matrix is the dimension of the column space. That's a very fancy way of saying it. It's easier to just notice that when you're finding dimension of a column space, what are you doing? Let's scroll up here and see what we did. Well, what I did was I said there are two pivots, so I have two elements here. So dimension is 2. Okay, so really I'm just counting pivots to find the dimension of the column space. I'm just going 1, 2. Okay. So you're just counting the pivots, and you need to have echelon form to be able to count pivots. Okay, and the rank theorem. The rank theorem, let's talk about part B first. Okay, this is something you've actually probably noticed already. Look at this exercise up here. If I look at, say, this matrix here, there are 1, 2, 3 columns. You have a free variable here, then you have a pivot column and a pivot column. And so you have 2 pivot columns, 1 free variable, and that's a total of 1, 2, 3 columns. Okay, so it can't add up any other way. Okay, the number of pivot columns plus the number of free variables always adds up to the total number of columns. Okay, so that's what we're saying in part B here. Okay, and I've written all that right here. Okay, for part A, it is again a question of counting pivots. If we look above, we've already talked about how finding dim col A is just counting pivots. And if you think about finding dimension of row space, it's the same thing, right? Because for every element in my row space basis, I have a pivot up here.